Yeah, so when it comes to the ETL world, okay, so ETL world is such a wonderful technologies here. Okay, so why I say it's a wonderful, and because of it's a user friendly. So how you feel comfortable to work with the Microsoft, you mean the Word, Excel, and the PowerPoint, the same way you can feel that much comfortness when you are working with the ETL tools. Okay, so there will be a comfortness. So it's a, because it's a purely a GUI based uh, tools, user friendly tools, so that it will helpful us to implement the ETL applications very easy manner. Okay, so that's the reason that all ETLs are so very user friendly. But when it comes to the world, ETL world, so the popular ETL tools are Informatica, Abinitio, Data Stage, and there are few ETLs even from Microsoft. They have their own ETL tool like that. Okay, so comparatively all the ETLs. So why the Abinitio? Okay, the question comes that if there are many ETLs in the market, what is the importance of the Abinitio? And even this Abinitio having the market. Okay, so I would like to say one very importantly, even though you're having the many ETL tools in the market, but leading ETL tools are Informatica, Abinitio, and the Data Stage. Okay, so almost like 90% of the ETL market captured by the Informatica, Abinitio, and the Data Stage. Only these three tools has captured the most of the ETL world. Okay, so that's the reason, the Abinitio, we can see many projects. Okay, so wherever the huge data, wherever the data frequency is there, there you can see the Abinitio. Okay, because the Abinitio is a powerful ETL tool. Okay, got it, guys? So let me share my screen. Yep. So let's talk about yeah, let's brief see the curriculum. So I think you already been covered this OLAP and the OLTP systems. Okay, let's talk about the ETL process, right? ETL ab initio. Okay, so when I'm talking about the ab initio, so what is ab initio? Guys, any idea? So what is the term says ab initio? Anyone? Hello?
Yeah, actually, the candidate doesn't know the ab initio. Like most of the
Mhm.
candidates, somebody are already working, but they blindly, like without having the background of the ab initio, they just
Right,
are using it will like a tool and all.
right,
You please give them the
right.
yeah.
Yeah. So, you know, so before you learn the ab initio tool, you should have some background about the ab initio. Okay. So when I'm talking about the ab initio is a Latin word. Okay. So there is no abbreviation for this. It's a Latin word. So this Latin word says from the beginning. Okay, from the beginning. So this Latin word saying from the beginning. So from the beginning, your process can be implemented, the extracting and transforming and the loading. Okay, as it is a ETL tool. So from the beginning, you can implement. So whatever application, whatever business logics you have, that you can be implement by using this tool. Okay, so whenever the question occurs, what is ab initio? So immediately we have to say ab initio is an ETL tool. Okay, so there is no other. So ab initio is a ETL tool. As I said, there are many ETL tools in the market. So why? What is the specialty of the this Ab Initio ETL tool. So as I mentioned, this Ab Initio ETL tool is a powerful GUI based, okay, GUI based ETL tool. So why I say it's a powerful? So even though Informatica also GUI based, okay, but when it comes to the Ab Initio is such a powerful ETL tool. So because when I'm talking about Informatica, so Informatica also one of the popular ETL tool. Okay, when I'm talking about Informatica, if you want to implement an application, so you have to come across the 5 different windows. Okay, so as part of the ETL, you have to extract the data, you have to perform the transformation, you have to load the data. So to do these activities, for extracting there is a separate window, for transformation is a separate window, okay, and the loading is the separate window. Actually the extraction and the loading part is a separate windows. With this, the transformation is a separate window where we call as the mapping. And once you create a mapping, you have to go for workflow, okay, to execute your application. Before you go for workflow, there is a session you need to create. Okay, so what I mean to say, even though it's a ETL process, is the small process, you need to come across the 5 different windows. Okay, whereas when it comes to the Ab Initio is not a, you don't need to go for different windows. Ab Initio can called as a single window architecture system. Okay, so when I'm talking about the ETLs, almost ETL tools are client server ETL tools. Okay, so client server, almost all ETLs. On top of that, Ab Initio can call as a single window architecture ETL tool. Single window. Okay, so this is one of the very good feature. This is one of the very unique feature to the Ab Initio, because you no need to go for different windows to implement your application like Informatica. Okay, so you no need to go for source is a separate window, target is a separate window, mapping is a separate window. So everything from the beginning you can implement using the single window. That is the beauty of the Ab Initio. Okay, am I clear, guys? So that is the beauty of the Ab Initio. So that's the reason, the Ab Initio term also defined from the beginning. Okay, so these are all interrelated terminologies. Okay, so understand Ab Initio is such a powerful ETL tool, the architecture wise. Okay, even if I'm talking about data stage, even for the data stage, you need to come across the different windows. Okay, so you need to come across the different windows. And the beauty of the Ab Initio is, okay, that is architecture wise. Okay, architecture wise, one of the advantage. What is the advantage? Single window. So when it go for execution perspective, even execution perspective also, the Ab Initio is such a powerful ETL tool. Okay, so why I say Ab Initio is a powerful when you go for execution. For example, I think you might have come across some of the ETLs or some of the programs. So whenever you write a program, what you need to do immediately? You need to go for a compilation or interpretation, right? So because the machine cannot understand your code. Got it, guys? So you have to convert your code into the machine understandable language. Okay, so where it's needed a compiler or interpreter. Okay, compiler or interpreter. So even for Informatica or other systems, they need a compiler or interpreter to interpret. Once you click the run button, first whatever you implement the application, that it converts into machine understandable language, then that code will deploy to the server. Okay, so as I said, all the ETLs are client server ETL tools, right? So client based will implement all the applications. So whatever you implement, the client based, those applications executes to the server side. Okay, so when I'm going for Ab initio, you no need to go for a different windows. There is a single window where you implement your application, and the place where you click the run button, the moment when you click the run button, the application starts executes. Okay, so because the corresponding the KSH will get generated by the Ab initio by default. Okay, that means by default the machine understandable code. Okay, by default the machine code generates by the Ab initio. Okay, so we'll get into this in coming sessions in a clear manner. So from now, just understand whenever you click the run button, so that application executes to the server side. So here you don't need a compiler or interpreter, because Ab initio, the moment when you implement an application, that application, the server understandable code automatically generates by the Ab initio. That is the code which it executes by the server. Okay, so we'll talk more into this in coming sessions. Okay, so let's see. Now I'm talking about what is the importance and what is the speciality of Ab initio when you are compared to the other ETLs. Okay, so already we covered the 2 points. Let's go for the third point, and which is very valuable. Uh, the Ab initio is meant for performance. Okay, performance. So performance, when the performance comes into the picture, guys understand, when the performance comes into the picture, whenever you have a large amount of data. Okay, whenever you have less amount of the data, we never ever care about the performance. Okay, so the performance comes into the picture whenever the data frequency is more. Okay, that means whenever that data high volumes, if you are having high volumes of data, okay, high volumes of the data, so then you need the performance. Okay, you have to think about the performance. So if the data frequency is more, so Ab initio gives you the best performance comparatively other ETLs, because of the parallelism. Okay, there is a wonderful concept uh, opted by the Ab initio, where you can perform the parallel processing. Okay, so by the help of that process, that can be handled high volumes of the data. So this parallel process can be scaled, can be optimized. That means can be scaled. I mean, can be increased. How many parallel process, if you want, you can do that based on your data frequency. Okay, so we'll get into this more into the coming sessions. So from now, you just understand the why Ab initio is a good tool in the market. So because of the performance, so because the Ab initio handles large volumes of the data. Okay, so that is a main asset of the Ab initio. Okay, so this is the advantage. It cannot be when you go for other ETLs, like for example, even I did it practically. I have seen practically when I worked for one project. I think like some ANZ. There I observed the Informatica graph. That means Informatica mapping. We converted it into the Ab initio. So Informatica mapping we converted, and we performed testing, because we need to compare the Informatica output to the Ab initio output. So when I execute the Informatica application, that has taken 3 hours of the time to execute that process. That is the same application when I implemented the same logic into the Ab initio, and when I execute this, so hardly 10 to 15 minutes that has taken to complete the job. Okay, so it's hardly like 5 billion of the data. So that has performed that has extracted, transformed, and loaded into the respective target, in ab initio in 10 to 15 minutes. So that much
Aditya, sorry for the interruption. We lost you.
variance you can see. Okay, where is the 3 hour time and the Mhm.
Sorry, in between
Sorry,
we
am I
lost
audible?
you. Yeah, yeah. Please go
Okay.
ahead. Please go ahead.
Okay, so this is the performance is a good asset to the ab initio. Okay, so because of the competition, guys, understand nowadays competition is very you know between all the customers, clients, you know so they have to give the best to their customers, right? When I'm talking about a bank. Okay, so previously what happens when the moment when you do the transactions, that reflects to the end of the day. Okay, nowadays it's not happening. The moment when you perform a transaction, that it reflects to your account, and you are getting immediately alert. Okay, so that is the beauty of the technology nowadays. So you know every customer, that means every enterprise, they want to give the best to their customers. So due to the competition. Okay, so due to the competition, so this is one of the good advantage to the ab initio, which it works very efficiently to the backend. Okay, which it works very efficiently to the backend. Okay, got it, guys? So I have covered like three important points, like why the ab initio. Okay, so what is the first one? What is the first one?
It's a
I covered.
client
Yeah,
server,
client server
and
ETL and
single
single
window
window.
performance wise.
Yeah, performance wise. Okay, performance wise, and the single window is from the beginning. From the beginning, you can implement your application by using the single window. You don't need to go for a different windows like your Informatica or Dataset or any other ETLs. So the place where you can implement your application, and the advantage is the place where you can execute your application. So there you don't need to have any compiler. That is one of the very big asset to the ab initio. Very big asset. I'm truly speaking, as I worked different ETLs. Okay, so the moment when you click the run button, or even for the production side, when applications are executing, the moment when it starts the application execution, just like that, within fraction of seconds, it kicks the job, and it starts execution. That is the beauty of ab initio, because ab initio doesn't require any compilation or any interpretation. Okay, by default, the machine understandable code gets generated by the ab initio. Okay, so am I clear, guys? So these are the very valuable points when I'm talking about the ab initio. Okay, I don't want to talk about who introduced ab initio, because that and all you can get it in the history. Okay, somehow in 80s or 90s, the ab initio being introduced. Okay, and there are multiple versions are there. Okay, so now let's the time to talk about operating system hardware platforms that are required by the ab initio. Okay, so I would like to talk about this. So what are all hardware systems, what are all operating systems required? Okay, and what are all hardware, that means yeah, hardware systems required to the ab initio. So when we are going for installation, ab initio can support any kind of operating system like Unix platforms, Unix, and mainframe systems, mainframe. Uh, then you can go for even for Windows, you can install. Okay, so this can be supported by the this kind of operating system. When I'm talking about hardware systems, it can be support the single system. Okay, the single system can be called as a uniprocessor system. Uniprocessor, uniprocessor system, and we have a SMP, and we have a MPP, and we have a cluster. Okay, ab initio can support the cluster. Okay, so let's talk about this. So how this can be worked. Like I'm talking about Unix. Unix means Unix is mm, there are many flavors you can see. Okay, so Unix is where you can see not exactly the Unix. You can see the Linux or HP, um, and IBM. They have their own Unix flavor like IBM AIX. Okay, IBM AIX and Sun Solaris. Like that, there are different flavors. So, what are these flavors exactly, guys? Anyone can answer this? How? What is these flavors? How they implemented? What is the purpose of this? Any idea on this? Okay, let me tell. Yeah, be interactive in the class. I think you have the option to unmute yourself. Okay, that's a one good thing you have to habituate when you want to get into the IT world. You have to speak, whether it is a right or wrong. You have to speak. Okay, so that is a habit you have to make it. You know, you have to habituate that. You know, talking. So when I'm talking about Unix, there are flavors. Flavors. What is this mean by mean flavors? Flavors means as Ab initio is a open architecture. Okay, as Ab initio is a open architecture. So Ab initio has their many flavors, but Windows is not a doesn't have many flavors because Windows is a closed architecture. So as Windows is Unix is a open architecture, so everyone has their open the Unix and they modified according to their products. For example, Sun Solaris. Sun Solaris, they have what is the main product of the Sun Solaris? That means Sun Microsystems. Java is the main, right? So to compatible to their products, they opened Unix, they implemented Sun Solaris. Okay, for example, when I go for IBM have their own products. To compatible to their products, they've opened Unix, they modified, and they introduced IBM AIX. Okay, IBM AIX is the one of the Unix flavor. So like that, we have Linux and HP, they have their own product. So like that, you can see the products like this in the market, and mainly when we go for real time, you can see a Linux or IBM AIX many places. Okay, so when I'm talking about mainframe also can support by the Ab initio, but we don't see in the real time. Okay, frankly speaking, we don't see the mainframes in the real time, but if it is there, OS bar 360 or 380, there is one operating system, that kind of operating system that it supports, but we don't see the mainframe with Ab initio in the real time. Okay, so when you go for Windows also it supports. Okay, so let me explore, let me elaborate this. Understand, guys, as Ab initio is a client server ETL tool. Okay, client. So when you go for a client, what are the operating system it supports? Understand, as you work to the real time, we are the persons, we work to the client system. Okay, got it? You will have client system and the server system. For example, who are all there in the call? For example, Charan, Dinesh, Guru is there. Okay, for example, Charan, Dinesh, Syam, or 4 members are working. Charan is there, and Dinesh is there, and I have Syam and Aditya. Okay, 4 members are working to a one project. So if the 4 persons are working to a project, Charan should have their own client. Say it is a client 1. Dinesh should have a client 2. And Sham should have a client 3. And Aditya should have a client 4. 4 different client systems. When you go for a server, but there will not be different server. There will be a single server. Understand, guys? There will be a single server. So to the single server, number of clients will be connected. So as it is a client server architecture, you should have your own, that means individual clients. Okay, so if the client 1 implemented one application, that it executes by the server. So here I want to say one important thing. So when you go for a client system where you can see always the windows. Okay, we don't need to worry about Unix or mainframes. Okay, so we'll be very comfortable. Uh, Whatever regular your personal system works with the Windows, the same way you work to the real time with the Windows. So when you come to when you go for server, okay, when it comes to the server side, it's going to be the Unix. I mean Unix flavor like Sun Solaris or okay, IBM AIX, like that. Okay, am I clear on this? Okay, so even if you have the mainframe will be to the server side, not to the client side. Okay, so let's talk about the hardware systems. Here we have a single system and uniprocessor system. So let's talk about this. For that, I just want to use some slides here. Okay, I think I don't have the single system. Okay, so this single system, I don't have the slide to the single system. Let's understand single system is, or uniprocessor system is like your personal systems. Okay, so like our personal system, the personal system, normally whatever we use personal laptops, the same way here. Understand here, there will be a processor, there will be a memory, there is a single memory shares with single processor and the single disk. Okay, am I clear, guys? There is a memory is a place where operating system installs. Okay, that operating system shares by a single processor and the single disk. So when it comes to the SMP is a somewhat SMP is better than the single system, because where you can see the multiple processor and multiple disks. Okay, understand, guys? You here you can observe the diagram. The yellow colored shade and yellow colored one are processors, and cylindricals are disks, and this in between, this is that is the memory. Okay, I'm repeating you, this is the memory, is the place where operating system installs. Here symmetric multiprocessing system is can be called as single window architecture. Okay, so SMP is a SMP is a single window architecture, because there is a single operating system which is shareable by the multiple processors and multiple disks. That means shared nothing architecture, we called as shared nothing. Okay, so single operating system which is shareable by the multiple processors and multiple disks. Okay, this will be in the single system. Okay, am I clear? Any questions to the SMP?
Yeah, may I know the abbreviation of SMP?
Symmetric multi-processing system. Okay, the
Can
name
you
itself
please come
says
again?
symmetric
Symmetric.
multi-processing system. Okay, so multi-processing, here you can see the multiple processors. Okay, these yellow colored are multiple processors. Okay, this is the fourth one is the this color, what this color called, this is the memory. Okay, and here is the disks. So memory is the place where generally it's a booting and will be happens, that is operating system will be shared by the multiple processors and multiple disks. Okay, so this is the system shared nothing architecture. Okay, and this is the system better than your single system. So when I'm talking about MPP, guys, understand this is the beautiful architecture, and this is the one which it happens to the server side. And when I'm talking about MPP, this is the example for the MPP. This is the example for MPP. MPP stands massively parallel processing system. Okay, so what is MPP? Massively parallel processing system. So MPP obviously better than, very powerful than your SMP. Powerful. So when I'm talking about MPP is the combination of or collection of or combination of nodes. So what is the node? Understand, node is a logical representation of the CPU. Okay, it's nothing but a CPU. It's a logical representation of the CPU for our understanding. So I mean, it node can be a single system. I mean, uniprocessor system or a SMP. Okay, I'm repeating you. MPP is a combination of nodes. The node is nothing but a CPU. I mean, it can be a uniprocessor system or a symmetric multi-processing system. Okay, so in the real time, most of the times, the combination of SMPs, we call the MPP. Okay, in the real time, the combination of SMPs. So here also you can find the diagram, which is the combination of SMPs, we call the MPP. So when you observe this is a very powerful server, which it works behind to the Abinitio. And understand, if you have 1 lakh records, okay, if 1 lakh records executes by the single memory, single processor and the disk, what happened? That it burdened to that particular processor and the disk. For example, if you have 4 systems which is running, which is parallelly executing, you have 1 lakh records. If 1 lakh records distributes into all these processors, then what happens? The performance reduces. I mean, the performance increases, the burden reduces. Okay, I'll repeat you, the burden reduces, then performance increases. So when it happens, when you go for this system as your server side, and if you have 1 lakh records, for example, if 1 lakh records, for example, if you don't have MPP, if you have SMP or single system, if it executes by that, there is a single processor or multiple processor which is running by the single memory, that it burden to that particular system. Whereas when you have a 4 system which it works parallelly, if this 1 lakh record splits by this split by these 4 systems, you know, the burden reduces, the performance increases. I mean, 1 lakh splits. Then when you split 1 lakh, what happens? Each system will get 25,000 records. Okay, node 1 executes 25, node 2 25, node 3 25, node 4 25. Parallelly, all these 25 records executes parallelly, and to the end it combines. Okay, don't get confused how to split, how to combine. All these magic we'll discuss in upcoming sessions. Okay, so now from this class, just you understand what is the MPP, so how it works to the backend. Okay, so understand guys, MPP is a massively parallel processing system. It's a parallel process. So parallel process.
Aditya, we have lost your.
Obviously, it's a works to the, yeah. Where, when, just minute back, or what is the last sentence?
Like
It's a parallel processing system.
Okay, so it's a parallel system, which it massively parallel processing system. Parallelly it works. If we have 1 lakh records, if 1 lakh distributes into all the nodes, when it distributes all the nodes, each node will get 25,000. So each system will get the 25,000. and these 25,000 records is the responsible to the particular node. Okay, so that's the reason this architecture called as shared nothing architecture. Shared nothing. Okay, why we called as shared nothing? For example, one node have 25,000 records. So these 25,000 records will not be shared by the other node. Okay, so whatever the node has processing the 25,000, that is the particular processor has the responsible for that particular 25,000. The data cannot be shareable by the other systems. That is the beauty here. Okay, that is the reason this architecture called as shared nothing architecture. Okay, am I clear, guys? Do you want me to repeat?
Yeah, it's clear.
Oh, okay, excellent. So if you have the same data is presented in all the systems, there is no use, and there is no concept of parallelism. Okay, so the same data will not be there in all the nodes. Okay, there will be a unique data will be there. Once some data receives to the particular node, okay, that node is responsible for all that data, if 20,000 or 25,000, whatever. Okay, so that's the reason it's a share nothing architecture, and it's a beautiful concept. Then what else? If I'm talking about MPP, massively parallel processing system, yeah, all the processors connects in a parallel way. That's the reason they named it as MPP. Okay, so and I don't want to talk about much the cluster, and here real time, what is the, that means here in this example, this is the MPP is the 4-node system. Okay, so how it happens when it go for the real time? So is it going to be a 3-node or 5-node like that? Generally they don't follow the 3-node 5-node like that. So they follow a formula, 2 to the power of n formula, to construct the MPP system. So where n is the number of natural integers, that means either 1 or 2 or 3, 4, like that. So I mean 2 to the power of 1 means 2 node, or 2 to the power of 2 means 4, or 2 to the power of 3 means what?
8 nodes.
8. Yeah, like this. Okay, so in real time you can see a 2-node architecture, or 4-node architecture, or 8-node architecture, or 16-node or 32-node, like that. So why they follow this formula 2 to the power of n? What is the reason? Okay, it's a simple reason. When you have this formula, it's a evenly the data will be distributed. Okay, if you have a 3-node or 5-node, there won't be an even distribution, right? So if you have 2-node or 4-node or 8-node, there is a chance of distributing evenly. Okay, got it, guys? Yeah, that is the beauty of the MPP, massively parallel processing system. I don't want to talk about the cluster. Let's because the cluster we don't see the real time. The cluster is a group of servers. It can be a SMP or MPP. But when we go for a cluster with the IP address, it connects all the servers. But whereas when you go for MPP, there a powerful bus layer, with that bus all the servers connects. That means all the inside SMPs connects. Okay, so let's talk about so when you are working with the client server, the client always the Windows. Okay, we don't worry about that. And when it go for system, this is also uniprocessor system, that is a single system will be there to the client side. Okay, so how you feel to your personal laptop, the same way there also you feel Windows is your client system. And when you go for a server is a Unix, and either SMP you can see or MPP, but always you can see the MPP as a server to your client side. Okay, so we don't worry about much how many nodes I required. uh, so we are the person, we don't decide that. So the customer will decide based on the data frequency. He decides how much configuration they need it. Okay, and how much the data they want to process. Based on that, they'll do the process. Okay, so we don't worry about we are the person, we don't decide whether 2 node is needed or 4 node is needed. So based on the data frequency, the client decides. Okay, so am I clear? Any questions so far? Okay, so I covered this point, hardware platforms, and so now the time to talk about the Abinitio architecture. It's a wonderful concept. I think we'll move on this concept to the next session. Yeah, I think 1 hour हो गया ना?
Yeah, actually, it's been 45 minutes. Yeah.
Oh, only 45 minutes. Oh, okay. Okay. So fine, because altogether it's a different concept, but it's a wonderful concept. Architecture is when we are talking about architecture, uh, it's there are different products we can see. Okay, so I'll give you the overview today. Architecture. Right. So I just go for overview here. Architecture. Uh, it's a very simple architecture when we compare to the other ETLs. Okay, so let's see. First of all, the first layer is the operating system altogether. On top of this operating system, the server installs, that is a cooperating system. Okay, so the cooperating system is the one which it executes all your applications. So all your applications, let's see, the first step is a user application. So to implement your application, you required a interface. Correct, guys? To implement an application. So that application called as ETL application. So that ETL application, so there will be a different terminologies when you are talking about Informatica. Informatica, where you called as mapping. So when I'm talking about a data stage, where you called as a job. Okay, when it comes to the Abinitio, the application we call as the graph. Okay, so the graph, Abinitio application is what? Graph. So you implement the application called as a graph. So you need an interface. That interface is none other than the graphical development environment, that is GDE. Okay, graphical development environment. Okay, so this graphical development environment is your application, which it always to the Windows side. Okay, and Windows side, that application which it executes by the cooperating system. Okay, cooperating system, bottom, from bottom to second. Cooperating system is your server. Okay, which it executes by the cooperating system. Cooperating system which is under always Windows, sorry, Unix, not Windows, real time, always under Unix. So understand, so this GDE is a Windows-based application, cannot understandable directly by the Unix-based cooperating system, so that it require a conversion. That conversion is a shell. Okay, so you can see in the slide, after the GDE there is a shell. Okay, so what is that shell, guys? This shell,
The Unix interface.
This shell is yeah, exactly, that is a interface, but shell program gets generated by the automatically generated by the ab initio whenever you implement the graph. Okay, whenever you implement the graph, the corresponding the shell program generates by the ab initio. This is the shell which it deploys to the operating system, which it executes by the operating system. Okay, so by using the GDE, while you are implementing your applications, so this is altogether GUI based. So you need some components. Okay, here we call it as components. So that is the reason ab initio provided component library. On whatever the library is provided, that you can use. On top of that, if there is any scenario which you cannot achieve by the existing libraries, then obviously you have to go for your defined. That means you can define your own functions or own program, that is user defined components. Okay, you can define your own. That is a beauty in the ab initio. So not only that, you can connect to the third parties. So their third party components. So all these things we perform by using the GDE. Okay, GDE is your graphical development environment, which is to the client side. Okay, so client is always to the Windows side. Okay, so understand the GDE, graphical development environment, to the client side. When it comes to the server side, okay, when you're talking about the server side is always cooperating system. So cooperating system is your heart of the ab initio. Okay, so once you implement an application, what do you call application? The graph. So when you implement this graph, so okay, for example, Charan implemented a graph. So that is altogether a different story. There is a sandbox and the EME comes into the picture. But now I would like to introduce the EME. Very high level, I would like to discuss. EME is the enterprise meta environment. Whenever you implement an application, you required some centralized repository to store your applications. Okay, to store your applications, you need a centralized repository, that is none other than EME. Okay, enterprise meta environment. Okay, got it, guys? So whatever user applications implemented by the GDE, that it executes by the operating system. Okay, to save all these applications, you required a place, physical area. That physical area is none other than the enterprise meta environment. Okay, which is based on the server side. Okay, EME also to the server side, not to the client side. Okay, which is not to the client side, which is to the server side. Okay, so to the server side, all your applications get stored, and the GD is the one of the product of the ab initio. So when you are talking about, not only the GDE, we have other products like Conductit, we have Expressit, Metadata Hub, and Control Center. These are the different products of the ab initio. Okay, understand whether you have a Conductit, Expressit, or Metadata Hub or Control Center. Always we need the GDE is needed to implement your applications. Okay, only the GDE is the way you have to implement the graphs. Okay, so GDE is 100% should be there. On top of that, you can have a Conductit or Expressit or Metadata Hub or Control Center, whatever is needed to your project. They can use it. Even you have a profiler, different other products also there. Okay, so these are the popular products. Okay, and when you go for a GDE here, the application you implement. Okay, GDE, you implement the application. that is called as the graph. Okay, so this graph is a data flow. Okay, where graph is nothing but a pictorial representation of your ETL process. Altogether, it's going to be a data flow. Data flow. So GDE always happens data flow when it comes to the conduct data. Okay, conduct it is such a wonderful concept. Okay, here you perform plans. Okay, here you perform the plans. How you call as the graph when you develop a GDE. Okay, when you develop a application under the conduct IT, that you call as a plan. So this plan is a control flow. Okay, so what is the control flow? So you have some extraction graphs. Okay, after that, based on your transformation, you have split it into multiple graphs so that you have some transformation graphs. Okay, and based on data volume, you implemented a separate graph for loading. Okay, so if you have extracting graph, transformation graphs, and loading graphs, so which one has to execute first? Always the extracting graphs has to execute first, right? There is a dependency. Okay, there is a control flow. What is the control should be? The control first extraction should execute first, then transformation execute second, and the loading. So all these controls we perform by using the plans. That is nothing but conduct IT. Okay, so that is the reason it's a control flow. Okay, such a wonderful tool provided by the Abinitio, where you can perform different kind of activities. So if my graph failed, what needs to be do? If the graph is success, what needs to be do? Okay, these kind of controls can be performed under the conduct IT. Okay, such a wonderful tool it is. Okay, so when I'm just giving you overall, that means in high level. Okay, so when I'm talking about the express it, okay, so express it is altogether is a validation tool. Okay, and it's a business oriented tool. Okay, then previously they called as BRE. There is I forgot the name abbreviation. Business something is there.
Business rule engine.
Yeah, business rule change.
Engine.
Environment, business rule environment. Okay, so BRE is now is like they developed as Express IT. Okay, so in the Express IT, where you can express uh, you can express your logics to validate your data. Okay, so Express is such a very useful tool which is for the analytical purpose. That means data analyst works closely to the Express data. Okay, so they want to analyze their data and they want to validate their data. So for that we have to create one Express application, and and it is a user friendly application, as the end users and analysts or layman of the softwares, they don't know how to write a query and how to program it, so they just need a simple click. Okay, that kind of interfaces we can implement by using the Express ID. Okay, that is a beauty. Altogether, it's a business rules can be incorporated to validate the data. Okay, so when I'm talking about metadata hub, okay, metadata hub is for the metadata. What is metadata? Okay, one of the standard thing you have to understand, guys. Whenever you are working with the ETL, so you work with the data. So you extract the data, you transform the data, you load the data. So whenever you are performing these operations, you have to identify what is the definition of the data. Okay, that definition of the data is none other than metadata. Okay, so this metadata hub deals with the metadata. Okay, deals with the metadata. For example, uh, for example, the banking sector. Okay, so banking sector, each field, whatever the fields which you are working in the project, everything is very, very important. Okay, we should justify each field. Okay, for example, source 10 fields are there, target only 8 fields are there, 2 fields has dropped off in between. So you have to justify why these 2 fields has dropped, or else you have 10 fields in the source and you have 12 fields in the target, 2 additional fields you have defined to the target. So I mean, when from the source to the target, how the metadata is, the lineage is happening, the data lineage. Okay, so that kind of activities we perform by using the metadata hub. Okay, so overall what you have to understand, so to justify all your metadata, so the metadata hub gives you the best solutions. Okay, best and user friendly, the lineage graphs, lineage, what I mean to say, the pictorial representations you can be seen very, very comfortably by using the metadata hub tool. Okay, so when I'm talking about the control center, okay, control center is altogether is a scheduling tool. Okay, so after implemented your plan is a control flow. Okay, one application, that application you have to schedule it. Okay, when it has to execute, or it is a daily job or weekly job or monthly job, or sometimes a quarterly job or yearly job. So based on your frequency, that job should be scheduled automatically. Okay, so that schedule I think you might have heard, I think few of them already working, so you might have idea about the scheduling part. Okay, scheduling is such a wonderful concept, and which is needed to the any tool, any application, whether you are working with Abinitio or any other ETLs or any other technologies. You require a schedule tool to execute your applications, and you automate the execute our application, you schedule the applications. Okay, so there are many tools like AutoSys, Control M. There are many tools available in the market, but when it comes to the Abinitio is provided their own ETL scheduling, own scheduling tool that called as Control Center. Okay, you can control your all your applications by using the Control Center when it has to execute, or if successfully done, and what needs to be do, or what is the dependencies and all, we can uh, give under the Control Center. Okay, fine guys. So these are the different products of the Abinitio and silent features of the Abinitio. Already we covered some of the unique features of the Abinitio. So Abinitio is it comes into the picture wherever you have the performance. Okay, that is the main biggest set, to the Abinitio. Okay, there are many features. Those are all generic features. Uh, you know, Data. Okay, they say the data warehousing. So many things they'll say, but one of the major feature is the performance. Okay, already we covered 3 or 4 very important features of the Abinitio. Okay, so okay guys, so then any questions now?